Awesome. Awesome. Ready? Good? Rock and roll? Let's do it. What's going on, everybody? Good afternoon. So by way of introduction, my name is Brandon. I'm an engineer at Cyberark. That's about it. If you have more questions about me and who I am, please come talk to me. It's really not important, but always glad to chat about it. And my goal today is to talk to you a little bit about some very quick wins in terms of securing cloud workloads, and also a little bit about securing DevOps workflows and pipelines. But there's another conversation happening this afternoon that'll likely go into greater detail, so I might be a little bit more cloud heavy for this one. We'll also, towards the end, hook you up with some free stuff that maybe you know about, maybe you don't, but we'll go in that direction too. And what I'll start with is just some historical information. Not historical like, Romans and crap like that, but historical like here's what's changed in the relatively short time that I've been in the security industry. And to get going, I think, before we start taking a look at bettering ourselves, we've got to come to reality with the stuff that probably every single one of us have done at some point, right? The security sins. I happen to have done every single one of these things in for the sake of going faster. Things like storing SSH keys in a hard-coded state, writing passwords down, right? Putting them on the board and say, this week's admin password is whatever. I have also personally gone through the Taco Bell drive-thru at night, parked and eaten it, just crushed it before I even left the parking lot. And I'll tell you, anybody go to Taco Bell today? I saw some people walk in that direction. Don't lie. So you thought about it though, right? You were walking by and you were like, mind is telling me no. Okay, never mind, doesn't matter. So, all these things happen, right? We have a tendency to forget that we're probably the worst practitioners of our own security. By the way, CyberArk does privileged account security. We vault passwords, we rotate them, all that good stuff. So I'm a little biased in terms of the security controls around it. Now, interestingly enough, even though we've had the same problem for decades now, right? Attackers get access to very privileged credentials. The world has changed significantly in the last 6, 7, 10 years. We've seen a modification of scale out there. If we've got, I saw some system admins kind of raise their hands up earlier today as part of the opening remarks, but back then, when you were setting up virtual machines, it took a while, even if you'd scripted it. At the end of the day, if you had 10 new VMs that you've provisioned, you've got the underlying application architecture installed, and you're feeling pretty good, pat yourself on the back. Now, with the move to containerization and the smallification, it's not a real word, but I'm going to go with it, smallification of application architectures, take nothing to spin up 1,000 new containers. So we see this huge shift in scale where it used to be one data center with a finite number of VMs. Now it's everything, every computer in the whole wide world, right? The cloud. Right? People come to you saying, what's the cloud? It's just other people's stuff. And it's also a lot easier to begin provisioning stuff out there. We're seeing more dynamic environments. So I mentioned virtual machines. So you would take care of them, right? You may still take care of them today. You patch them. You perform updates. If something is broken, what do? You fix it. Why is this broken? I'm going to fix it. They're like pets, and you've heard the virtual machines are like pets and containers are like cattle. It's a little slaughtery for me, so I like to think of it like Kleenex, right? You don't think about it. Pull a tissue out, you use it, whatever you do with it, and then get rid of it. So we're seeing that shift, right? Things are no longer persistent. We're moving to a more ephemeral architecture for both our applications, but also human access stuff, too. And because of this non-permanence, we tend to think a little less about the amount of security we subscribe to it. The same is true for environments that are no longer homogeneous. Around, I'd say 3 or 4 years ago, if you went to someone and said, hey, what cloud provider do you use? They would say, well, I use Amazon Web Services, and that's all that I use. Brand loyalty ain't a thing anymore. They may say, oh, well, yeah, we use an AWS, but I got this group over here that uses Azure, and I hate them, and I also have these people over here using GCP, and then we got those cats over there who are using Pivotal Cloud Foundry. So we now have all these different things, all these different vendors, providers, infrastructure as a service people, so nobody's sticking with brand loyalty. And the same could be true of your network devices, too, right? You may have been a Cisco shop, but now you've got some other stuff, too. Because we're automating more processes, we also have more non-human actors. The old adage was, for every one of us flesh and blood people, there were 3 non-human, very privileged service accounts, right? Ones with a lot of power. I'll submit to you that today, that number could easily be, or ratio could easily be 1 to 5, even 1 to 10. More automation means more robots. More robots means that eventually we will bow to our robot overlords. Or in this case, we just have more non-human entities running around out there. And I'll talk more about that dichotomy later. Finally, us, the people who support it, secure it, who potentially break into it, we are now given more privilege than we need because we have to deal with all these privileged robots running around. So we become kind of the privileged wranglers, and some of us, many of us in this room, more than likely, I'd say 100% likely, we're experienced enough to be able to handle that level of privilege. A newer system admin might not be. So we're seeing a lot of shifts out there in the wild. Problem is the same, as I mentioned, but now because of these things, we're seeing more and more breaches that occur, not because an attacker, one of you potentially, went through the lateral movement process. It's because we get lucky on that first hop because of all these different changes in dynamism and additional ephemeral secrets, all that good stuff. So we're seeing more and more stuff just happen because we were slightly negligent versus the gross negligence that you would expect. I'll submit to you that the process remains the same. The goal of a bad guy, of us, is to escalate privileges somehow. We used to have to work for it. I'll talk to you about how we don't anymore. Move laterally, elevate those privileges, then exfiltrate and profit. That was kind of the process that we go through. We still see a lot of APTs operate like this. However, I'll show you some ways that it's become a lot easier. Now, the old way, as I mentioned, was to hack a data center, right? You did your work, you did your reconnaissance, you infiltrated, you worked your way through. Now, because everything is being centralized in these different cloud providers, all you have to do is make that one hop in. If you compromise a human being's access at the admin level to a cloud admin console, you are done. No movement is needed. The cloud has made lives so much easier for penetration testers as well as bad guys too. And we see this over and over again in exercises. So CyberArk has a red team. Our customers can contract us to not only test the security of our solution, but just in general of the environment. We have seen this same scenario play out in, I think, a handful of different occasions now. So in this one, we got called by a financial institution to test, in this case, it was the security of their cloud environment. So standard phishing email came in, found, I kid you not, a notepad doc that said AWS on an administrator's system. Pop that open, there was an access key and secret key pair sitting right there. Now keep in mind, these people were using a password vaulting solution. They were rotating domain admin accounts. Here it is. Access key, secret. We used that to attach their S3 buckets to our instance. We found PII. We found customer names, social security numbers, credit card numbers, in this case for the processor. But you don't need to do that, right? You don't need to take advantage of a user's negligence. If a user's leveraging AWS CLI on their system, there's a neato little credential cache file that stores the access key, secret key pair for you. And folks typically will say, well, what do you mean? Why on earth would Amazon let that happen? Well, it's responsibility differences. Amazon, Google, Microsoft, anyone who is offering software or platform or infrastructure as a service, they are responsible for the security of the cloud. All the compute, network, all the pieces, the plumbing that goes into it, that's their job. It doesn't change the fact that our job is to still be the custodians of our own data. We are responsible for the security in the cloud. Right? Just because I put identifiable data into another provider's, in this case, database or backend that's supporting it, that's still my stuff, it's still my job. And we're seeing this kind of, not really breaking, but this more of a trust but verify model as we see a number of cloud breaches, also availability concerns that occur. It's not the cloud provider's problem, it's ours for assuming that everything was going to be okay just because it's not something we can physically touch. So we recognize that there's a potential issue. How do we fix it? Well, the first way to do it is where we'll typically start. Look at your human access. Right? Every vulnerability is caused by one of us. There's no way around it. We are beautiful biological machines that have a lovely tendency to trust stuff. That's just how we are. That's how we survived as long as we have. And because of this, we can use that same inherent survival instinct to instantiate identity and security onto people. Now, when it comes to the cloud, that means admin-level access into that cloud management console, the one-stop shop to be able to compromise. In this case, I've got AWS and Azure up there, but really any cloud platform. First thing you can do, if you haven't, I'm sure you are, put multi-factor in front of that bad boy. There is no good reason why a user should not go through a ton of pain to use the root account. There's really no reason they need to be using root in a cloud environment anyway, if we're doing things like federation. So if they have to use it, right, make them hurt a little bit. That's kind of a loud noise there. Sorry about that. We still don't have accountability if we're doing that multi-factor, right? So for instance, if I've got that shared account, I put multi-factor on top of it, that means that Brandon, person X, person Y, person Z, all these different folks could be able to perform that challenge. So how do I know that Brandon was the idiot that came in and made these changes? I really don't. So there's still no accountability with that MFA. Doesn't mean you shouldn't do it. Do it. Put MFA there. But also, look at ways of being able to, I don't know, store that account somewhere, rotate it. Look at ways of bastioning connections, whether you use a remote connectivity software, whether you're doing ACLs from your internal network, something like that. Combine the multi-factor with an audit trail that lets you know what user was doing what stuff, if they have to use root. If they don't, use federation. Keep doing that. But also, if you're building all of these different security practices for one in-cloud environment, don't assume that it's going to stay like that. As I mentioned earlier, environments aren't homogeneous anymore. People are adopting multiple platforms. So create a strategy today for what you're going to do when the C-level comes down and says, dude, we're going to use Azure. Okay, I got a plan for that. So think of that. Now, I mentioned federation earlier, and in the past couple of weeks, I guess almost month at this point, we've all been a little concerned about the same SAML 2.0 that we got really excited about. And there are some inherent problems, just generally, not like an issue, but problems with a protocol like SAML. So many of you are probably familiar with the flow, but the way a SAML 2.0 request looks is you've got three players. Your identity provider, your client, so you, right, the person on the system, and your service provider. If you look at the flow, you start to realize where some things could break down. Client hits up the service provider and says, hey, dude, I want to log in. Service provider says, I don't know you. So then you say, oh, so I got to go through SAML. So you pop back over into SAML, perform your authentication there. That generates a neato little signed request for you. That then you just pass back to the service provider. Service provider says, ooh, I trust this. This looks good. The authentication is completed. The problem here is that the service provider and the identity provider don't talk. They rely on the client, which means if I wanted to break this, in addition to taking advantage of any vulnerabilities that may exist in the protocol, which we found very recently, I compromise the client, even compromise the IDP potentially. And this works really well for stuff like ADFS, which could exist on-prem. So CyberArk has a division of our R&D team called CyberArk Labs. And we were playing around with this a little bit and actually found a way that through compromisation of one identity provider node, we could generate fraudulent signing requests and provide them to the service provider. It's not a vulnerability. It's the way the protocol should work. All we need are just a couple of little pieces of data to make the magic happen. And because it seems so close to Golden Ticket, we just called it GoldenSaml. Works okay with two-factor. You can generate authentication from wherever, but the best part is it's not a problem. There's nothing vulnerable about it. It's just the way the protocol works. So as an example, if I've got access to the things like the attributes needed, the public key that's needed for signing, and a user's system, I can take advantage of that three-step process I mentioned to generate the actual request and response right on my user's system. So I've got my SAML here. We have a tool called Shinit that I'll show you where to find later that takes the attributes and the private key and generates that request. You pass that fellow on to your service provider who's trusting your IDP. Boom, bam, you authenticate. Life is beautiful. So this is a thing that we call GoldenSaml. We do have a tool out there that lets you generate these requests. It's available on our GitHub that I'll show you in a bit. The point here, do not assume that your identity provider is secure. Always, always, always challenge your vendors. I don't care if it's us, if it's your multi-factor provider, if it's your firewall folks. Challenge the security at that layer and never trust new protocols. And I say that like I'm like an old school guy. I say, don't trust the new stuff, but don't. Right? We're moving a lot faster than we used to in every organization in terms of development. This quick agility, that's redundant. This increase in agility is causing us to lose track potentially of some of the security tenets we would have had in place if we were doing something like a more traditional agile model. So for cloud, don't trust people, duh. Make sure you're securing human access. Don't let humans use shared accounts unless they absolutely positively need it, and make it really hard for them to do it. But what about those robots, right? 1 to 10 I mentioned earlier. What about those other 10 identities? Ever since there were mainframe applications that had hard-coded credentials and configuration files, there's been a problem. You get access to that file, you get those FTP credentials, you get those batch processing credentials, you get that data, you're made in the shade. Applications do not operate with non-privileged accounts. They love them. They eat them up like their Fruit Loops at the hotel breakfast this morning, which, not going to lie, I did enjoy some Fruit Loops this morning. They were delicious. But in any case, it's there. But what's changed a little bit is getting to a mainframe is some work, right? Assuming that that mainframe has a security package on top and we're not just talking about telnet communication, you've got to get into an environment, get to a mainframe, which is typically in a weird isolated segment, and then find the file. What's happening with that move to a more automated model is things like this, which is an access key secret key pair living inside of a Jenkins build script, happen to make their way to public repositories all the time. If you were to go onto GitHub right now and search for AWS_secret_key, you would find tons of hits. It's easy to forget to scrub this type of information and push to a public repository. We saw that with Vine. We saw that with Uber. More recently, we saw that with Tesla. It keeps happening over and over and over again. And it's not because we're not doing best practices. It's because we forget, because we're people. So more and more of these hard-coded secrets are making a beautiful threat surface for us. In fact, if you look at Jenkins alone, it is a voracious consumer of secrets. It authenticates to everything, and it's really nice about it, right? Jenkins just wants to help out. Just doing one thing, like pushing a brand new Docker build, requires 4 different transactions. Docker Hub, Docker Registry, GitHub, backend databases or systems where you're provisioning the applications, and something else that I can't remember. It's all up there. It's going to happen. So how do we secure these? Well, first of all, we got to talk to our developers, which hurts. So in many cases, we'll start with the things that we know. As security, we know there's going to be vulnerability scanners out there. We know those use privileged credentials. I'll talk about them a little later. It's a great first place to go. We know there's going to be CMDB discovery, orchestration processes. It's when we start getting into the config management stuff like Ansible, Chef, and Puppet, or stuff with Jenkins, that we've got to go talk to another team. And to them, all we're really trying to do is make their lives a living hell. Because now they have to do one little thing different, or tweak one little piece of code, or heaven forbid, they have to go somewhere else, find it, and then paste it into their hard-coded stuff already. So just having this conversation is a nightmare. So my recommendation would be, just break it down. Here are the things you don't do, right? Don't hard-code stuff if you don't have to. Don't do things manually. And your developers and operations engineers are going to say, heck yeah, I don't want to do stuff manually. You don't want to do stuff manually? I don't want to do stuff manually. Like, automation is the key to everything. Don't ignore auditing. Right? Please don't. There should be a way to audit. What's going to happen when you tell them this is they're going to say, well, how? How do I ignore auditing when I'm using application service accounts? How do I not embed secrets in source code? How do I do all this stuff? And now you have a conversation where you can give them those best practices. Developers like to learn. We do. It's just opening up that conversation that tends to be a little, well, for lack of a better term, intimidating. The other thing that you'll see a bit is when you have this conversation with developers or anyone who's even adopting a little bit of the DevOps framework, they'll say, oh, no, I've got a spot to put it. I have a place to put my secrets. Well, what do you use? Oh, well, we use Chef, and we use Ansible, we use Puppet, we use AWS, KMS. Okay, and then they say, well, we put them in data bags and Ansible Vault, and we put them over here in AWS KMS, and then we put them here in the Docker or Kubernetes secret stores. So you've got 5 different places where you're managing these secrets. Well, how do you orchestrate it? Well, we don't. Well, how do you rotate them? Well, we don't. So why not put them in one spot that has integration points with all of these, or doesn't even need to talk to them? So when you're looking for a way to begin managing some of that privilege, make sure you ask the questions, right? Can we replace these tools potentially that our developers are using as a stopgap? And this is if we get lucky and they're doing it at all. So some good practices when it comes to non-human secrets, right? Make sure we're encrypting them, rotating them, automating any pushes, make sure we're auditing stuff. This is all kind of, it's all, what's the word I'm looking for? It's obvious. It's all obvious stuff. These are things we need to do. But again, the problem becomes, how exactly do we do that? How do we get to a point to where we're managing secrets and we're happy on the security side, and developers aren't lining up outside of our offices with torches and pitchforks and trying to light our desk on fire? Well, do it by allowing them to make small changes or no changes to code, make sure their workflow changes very little, do it through native integrations, and maybe do it for free. That's kind of important. Centralization is good for you. Free stuff is good for them. That doesn't need to be a project. There are tools out there that can help with this. I'll share some of them with you in a bit. Now, what may happen is folks may say, well, we don't have a problem with hard-coded secrets. So if we look at an orchestration process, just a very simple one, we've got 3 exchanges that occur. Your orchestration server thingamawobber has to authenticate to do its job. Typically, it uses a privileged account to do so, right? Of course. Once it does its job, you now have a new thingy. It could be a new container host. It could be a new virtual machine. It could be a new instance. That new thing has a privileged account associated with it too. And if you don't put it anywhere, they're probably all going to be the same across the systems. Or we'll take advantage of whatever our provider gives us and then hard code it somewhere and maybe never change it. Once your application is provisioned, right, because we typically build stuff so that it does stuff afterwards, that application then authenticates to databases or to whatever it may be to do its job. So I submit to you, find a spot to put those, as I mentioned earlier, replace the orchestration user with a call back to that secure spot, and I'll talk about some of the fallacies with that. Onboard those new accounts programmatically and make sure they're rotating so you don't have lateral movement risk in your orchestration. And finally, I don't know, replace the hard-coded credentials in your applications with calls back to that same store. We went from happy to bad, or bad to happy in that order very quickly through 3 processes. Now, it tends to get pretty rough, though, when you start actually doing some of this. And one of the biggest challenges you'll see is the dichotomy between identity and security for people, like us, it's us again, versus ones for machines, not humans. People are personable. It's very clear that someone has an identity, a role. They can give you an ID. They can give you their name badge. They've got a briefcase. Maybe if they still carry a briefcase, it has stuff inside that shows you what they do. An application is the exact opposite. It's cold and unfeeling. You don't know what it does unless you talk to somebody, and nobody likes to talk to people. It's very hard to identify its identity or its role unless we've named it something super, super obvious like Qualys _ADM _SVC. So we'll start with people first. Applications won't get the same love. People can multi-factor, applications can't. So those calls I mentioned earlier, our tendency is to authenticate using API keys, but what do we do? Right? If I have you authenticate to a secure store with an API key to pull a secret out, I replaced one secret for the other. So the goal is to use attribute-based authentication. Authenticate an application based on what it is, not what you can hard code inside of it. Things like hash, run as user, file path, whitelisted host, a combination of those. Container ID, pod identity, sidecar container. I don't care. Don't use a hard-coded API key. By doing that, by giving applications identity, we bring them closer in parallel to the same people that we start the process of securing first. That wasn't WA113. Man, that was Wally. We know what he does. We saw the movie forever ago. We were forced to watch it. So find a way, and there are people who can help, to bring humans closer in parallel, or in parity rather, to our applications. And also, as I mentioned, do it with the secret zero problem in mind. Approach it equanimously. We cannot authenticate with API keys in order to secure other API keys. It just doesn't make good practical sense. Now, I will end with this, because I think we have, we're still doing pretty good. We're still doing pretty good. So I'll end with the most important part of the talk. Well, in a moment. First, human access into the cloud, programmatic access into the cloud, programmatic application accounts, all three of these items we're seeing be drivers in breaches. The breaches that don't have 89 days of potential hanging out and reconnaissance. The ones that happen fast, why not just do the cloud accounts? Why not just go with what we know, what's sitting right there in front of us? And there are ways to begin to mitigate that risk without having to talk to anybody. There's ways to do it using free stuff. So I'm going to talk to you a little bit about some free things. Now, I'll do it in the context of what CyberArk does. If you go on to GitHub or Google and you type in these things, you'll find some good open source projects out there too. So don't just rely on one particular vendor, one guy up here who happens to be a little bit biased. So a lot of times the question is, well, dude, yeah, there's a problem, or dude, I know my customer has a problem, my client has a problem, how do I start? Well, you can take a look at the environment, right? Maybe run some kind of scan. And like I said, there are tools out there. 2 years ago at DEF CON, Bloodhound was released. If you've used Bloodhound before and you like it, there's a solution that CyberArk provides called DNA, or Discovery in Audit. We actually were in the room when Bloodhound was announced, and after we all dried the sweaty excitement that was going on in that room, we said, man, that's like DNA's like long-lost cousin right there. So what DNA does is, instead of looking at like AD trust, DNA will pull back information about the accounts that we find out there. Things like Windows accounts, and Unix accounts, and hard-coded credentials for J2EE application servers, and in Ansible playbooks. Things like hashes and SSH keys. We take all this info and we shove it into this really scary report that shows information about what we found. Now, you can use that as a way to guide you in your security practices or your breach practices, or you can use it as a way to mitigate risk right away. So, for instance, we ran DNA as part of a proof of concept with a financial institution in South Florida around 2.5 years ago. We found some pretty good stuff. Right? Every time I've run this thing, we found neato stuff. And I have to like try and act surprised, like, no, that's never happened to anybody else. It happens all the time. So we ran the scan, and there was this one account. It was a domain admin level account. The password was old enough to drive at that point, and it was attributed to one individual, first initial, last name. I said, who is this cat? Who is so negligent with their account that this happened? By the way, hashes were everywhere. I don't know if I mentioned that. Hashes were everywhere. And I was working with the CISO at the time, and he kind of put his head down. He was like, that's the CEO. What? I mean, the most visible employee in a company has hashes all over the place and the super old password. And is in the domain admins group. Yup. Why? I didn't want to get fired, Brandon. That's why. I'm not going to tell the CEO that I'm going to pull his access. That's crazy talk. Okay, well, maybe think about it. So CISO picked up the phone, called someone. They removed him from the admins group, had a change on next login. 3 hours later, the CEO calls, and I'm like trying to get out of there, like running. Because the guy's going to chase me down. It's going to be my fault. CyberArk's fault, not me. It's fine. So we mitigated some risk right there. The only thing they had to put up with was me just kind of hanging out and showing them how to get the scan started. Next day, we go back in. We're still a POC. We're doing work. We're managing stuff. So we go back in. We can't get started. We're hanging out in the lobby, just kind of waiting. They're like, it's a Sev 1 issue. Like, you're going to have to wait. Okay, cool. So we're chilling out in the lobby. They come pull us in. I say, of course, being, a little too inquisitive for my own good. I'm like, well, what is it? What happened? It's like, there's a problem with our vulnerability scanners. Well, what was it? CEO's account was actually, that was the account that was being used for authenticated scans. What? You mean the most visible employee in the company had a super old password, and it was the service account for vulnerability scanners, meaning as a bad guy, I could come in and totally fly under the radar, and you would just be like, oh yeah, man, just vulnerability scanners doing its own thing, man, just doing what it needs to do. So what'd you do? Well, we changed it out. Fantastic, great. So mitigated more risk. No money was exchanged at this point, only time. So 6 months later, they became a customer. We were having just kind of a standard cadence meeting, how's everything going, what's going down, and they were like, so you want to hear something funny? I'm like, yeah. So we talked to the help desk. We found out that the CEO's account was being used as the help desk's backdoor service account. At this point, I wasn't surprised. I was like, well, why? Well, so we found out the password was just super easy to remember. Great. So DNA helped us with that. Again, no cost. If you let us know if you want more info, but we give you a license. Feel free to run it as you'd like to. We can help you. We can analyze the results. We can do all kinds of cool stuff, but free. So once you find all the scary stuff, right? Once you've shared it with the teams and you freaked some people out, where do you put this type of stuff? Well, you could buy a solution, which, I mean, if you want to, or you can use something open source as well. So Cyberark offers a secrets management platform called Conjure. That's a fully containerized secrets management piece. It's available at conjure.org. We've had this thing for we've been doing it for about 5 months now. We've seen, I think, our community Slack blow up. I think we've seen like 6 or 7 times of an increase of the folks who were there in the first month and the folks who are there now. At the very least, head over to conjure.org and join the Slack if you just want to ask questions or talk to developers who work in privileged account and privileged secrets management. There are other tools out there and available. TrustedSec recently put one out too, so you don't have to just rely on one vendor. But please, if there isn't a project, use stuff that's open source. It's better than doing nothing. It's better than having those spreadsheets. It's better than having those hard-coded secrets. It's better to do something. Right? Finally, just some information. We've got conjure.org there. That's where the open source secrets management thingy is. We've got Shamit, which is the tool that's used to generate signed SAML requests if you have a private key available. And then if you just want to spam somebody, I'm the best guy to do it. Please feel free to hit me up. So, thank you so much for the time. Any questions at all? Anything? Okay. So I got a quick story about this. So I totally stole this. Hacker Dave did use this in his presentation in Columbus BSides last week, and I'm pretty sure I ruined the presentation by just sitting in the back and laughing. I don't think I did, but in my mind I was just laughing like an idiot. But yeah, so thank you all so much for taking the time. If you have any questions, please come find us. We're hanging out. We got a table. If you just go over to the table and grab some free stuff, that'd be great. Otherwise, thanks everybody again. Actually, just going to leave this.